Great Kangaroo from 2024 from UKMT. Let's get to it. So counting the corners or the vertices is just 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, which is 12 of them. Here we could multiply 20 by 24, but I can't be bothered. This denominator is just 8, obviously, and then you can do 24 divided by 8 is 3. 20 times 3 is 60. Here it's tempting to say that the answer is 3 factorial, just because there are 3 counters and you just need to arrange them. But doing 1, then 11, then 5 gives you the number 1, 1, 1, 5. And doing 11, then 1, and 5 gives you that same number. There's only 4 ways of doing it, because you just mess around with where the 5 goes. So there are only 4 ways, therefore, of doing it. The maximum weight is 12 large packages or 20 small. If you've got 9 large in there, you're using up 3/4 of the weight that you can use in the lift, because 9 out of 12 is 3/4. So you've got a quarter left. So you've got, and if the maximum amount is 20 of these, you can put a quarter of them in, which is 5, and that will be our answer. The only way to make 4 is 2 times 2 or 1 times 4. Just guess that it's 1 and 4. I mean, you don't really have to guess, because if you put a 4 here, you can't multiply to make 6 using integers. So therefore, this will be a 6, and this will be a 2. It all works out. You add them all together, you get 13. Next, we have some trolleys stacked together. 4 of them are 108 long, but then when you put 10 of them, you get 168. So therefore, the extra 6 extra trolleys stacked in here make a distance of 60. So therefore, each extra trolley that you put into the row adds an extra 10 centimeters. So going back into the first example, each extra trolley is 10 centimeters. Take away 30 centimeters from this amount, and you get that the original trolley is 78 centimeters. Here we have all these slices. There are 9 of them, but there should have been 10. So therefore, each slice is 36 degrees. Now, if you're putting in 9 of them in here with gaps, that means 360 divided by, that means 36 times 9, of course, we're missing 36 degrees, the missing slice of cake is being split between all these gaps, I guess we could say. You could do 36 times 9 and take it away, but just think about us missing 36 degrees in all these gaps. 36 divided by 9, because if you count up, there are 9 gaps. That gives you 4 degrees per thing. We just need to find some way of putting these together to make a square and with the thing that's missing. First thing to note, though, is that this row must go together. So therefore, all of the rows add up to 7, and the columns and so on, because this row adds up to 7. So we'll put that maybe at the top, and then I can maybe slice this one in here, and maybe put this one in the middle there. And now this all works pretty well. We have a gap of 1 down, of 1 by 3 down here, which is fine, because all these are that answer. We need the first one. If everything else is 7, we need this to be a 1 to make this into a 7. We need this also to be a 1. The only one that starts 1 was this, so therefore it's the answer. It also works for the last thing as well. This is quite an interesting question. We don't know where this point is. Now, it's a square, and we can put 3 things in it, 1, 2, and 3. Pretty clear that this one is supposed to go down the corner, top left to bottom right. So put that in. But we don't know where this cut is. It could be quite far over here. It could be all the way over there. There's no indication as to where that's actually coming from. There's nothing in the question that tells us that it needs to be anywhere in particular. So what I'm going to do is I'm just going to put it right at the very end, there, which makes this P and this Q, which are equal, of course, by symmetry. P minus Q is 0. And because there's nothing in the question telling me I can't put this line here, and therefore this line here, if this isn't the answer, then there isn't an acceptable answer, right? Either this is consistently 0 wherever you put it, or it changes wherever you put it, in which case I can't answer the question because I don't know where to put it. So therefore the answer must be 0. Paula the penguin goes fishing every day and either gives 7 or 5 fish to one chick, who gets 44. So we just need to find a multiple of 7 and a multiple of 5 that add to make 44. The fact that the 5s end in 0 and 5 makes it quite nice, because then you're either looking for a multiple of 7 to end in 9, which it doesn't, or 4. So it's going to be 14 and 30, I think is the way to do it. So this fish here gets 2 days of 7 fish and 6 days of 5 fish, which means the other fish is getting the reverse, right? They're getting 6 days of 7 fish and 2 days of 5. That makes 10 plus 42 is 52 in total. Question number 11, we just need to stick extra cubes on every face of this object here. So obviously, like on the end of this face, we can put a cube, likewise there, likewise at the back there, and there, and then maybe at the bottom and the top. Now, the interesting thing is what happens when you attach a cube to this face here, because that actually also attaches a cube to that face. So we don't need to count these faces separately. All we're going to do is say there'll be 1 here, 1 there, 1 there, 1 there, and likewise on the bottom, and likewise around the middle. So that's going to be 12, I think. That are all the doubles, and then we've also got the 1, 2, 3, 4, 5, 6 that just go on the ends of everything, and therefore that makes 18 in total, I think. Just count carefully, and you should be fine. Uphill, you cover 1 meter per jump, and downhill, you cover 3 times as far. So when you're going upwards, you're going to cover some amount of jumps. When you're going down the hill, he's going to do 3 times as few jumps because the distance up and down hill is the same, but you're covering 3 times as far with each jump. So the ratio of number of jumps that this thing does is 1 to 3. Or 3 to 1 if you write it uphill to downhill. So making 3 times as many jumps to get up the hill. That means you're making 4 parts in total, and we can just split the total number of jumps into 4. So that makes each part 506 times by 3 times by 1, and that makes this many uphill jumps to this many downhill jumps. At this point, we can just say, well, he's covering 1 meter per uphill jump, so therefore going all the way up the hill is 1,518 meters. If we double that, because we have to go up and down the hill, he's going to do this far in total. Good. This is some nice little theory where these perimeters, I'm pretty certain this one and this one add up to make the same thing as this one and this one. If you know that theory, you can just immediately say that the answer is 10. If you don't, you can do a bit of algebra, and I think you can do some algebra to prove that. I might be wrong about that theory. I know it's true for area, and I'm pretty certain it's true for perimeter as well. I didn't actually bother to prove it. Anyway, let's call this little distance A, this one B, this one C, and this one D. We can obviously say that A plus C is 9 because 2A plus 2C is 18. So just A plus C is 9. B plus C is 12, half of this, the semi-perimeter this is called. And D plus B is 6. It's half of 16 for 8. Now, if we add all of these things together, all 3 rows, we'll get A plus 2C plus 2B plus D equals those 3 numbers added together, and we're aiming to get A plus D, of course, right? We want the semi-perimeter. We can just double it afterwards, right? If we get the semi-perimeter of this one, we can just double it. But looking at this here, 2B plus 2C, well, that's just 24. 2B's plus 2C's. So to replace that with 24, take it away from both sides and get A plus D is 5. And of course, double that to get the perimeter of this shape. 2A plus 2D would be the perimeter, and you get 10. For this one, think about the possible lines of symmetry. It's possible to be symmetrical across, down, and then through this diagonal and through this diagonal. Just take each case on its own. So if I'm doing symmetry going down, I think this is going to be the only way to do it because you have to fill in that square and you're going to have to fill in that square. You've only got 2 squares that you're allowed to fill in. So that's the only symmetry going down. Symmetry going across, we're going to have to fill in this square and this square. Cool. Symmetry going diagonally, I can't remember which one I did first. It looks like I did this one first. Possibly. Oh no, this is this one. Cool. So symmetry going this way, going to have to fill in those two, and I think that's all you can do. And then symmetry going this way, because this one is already symmetrical, you're going to have a lot more choices here. You have to fill in this one to make this one match, but then you can just fill in any of this, this, or this to make that still fine. And we'll end up with 1, 2, 3, 4, 5, 6 ways of doing it in total. For number 15, we have numbers 1 to 9. Now, all these people are telling the truth. So what I just did was list out the possible things they could have. So if Aleska's numbers add up to 6, she can possibly have those 2 pairs. For Bart's difference of 5, those are the only options he has. Clara, these 2, and Deandra, I think, these ones here. And just run this through. So I started giving Aleska these 2, this pair. And that means that no one else can have the 2 or the 4, obviously. So that gets rid of this person being allowed this or this, gets rid of this person being allowed this or this. Clara isn't allowed the 2 or 9 because Aleska's got the 2. So she must have this. But then you notice you've banned 2 and 3 and 6. And I think 6, 2, 3, who doesn't work here? Oh, and you've banned the 4. So Bart no longer has anything to take from here. So it can't be this, then this, and it can't be this, then this. So it must be starting here. That doesn't ban either of these 2 things. So I just guessed, after I got rid of a few pairs that other people aren't allowed anymore, I just guessed this one. And I got rid of this, actually started crossing stuff out because it's easier to see what you're doing if you do that. I then gave Bart this one. I think there's no reason he can't have this one, is there? Just yet. If he takes this one, that bans the 4. And so then Deandra can't take anything, so he must take this one, which means Deandra then takes this one. And since this is a viable solution, there's nothing stopping me from saying the answer is just the number that's missing from all of this, which I believe is a 9. Everything else being taken. So, okay, cool. Answer of 9 is acceptable. For this, I just stared at these numbers and found a way of doing it. I don't have any more advice other than that. Probably a good idea if you would actually bother to list out how many vertical and horizontal each number has underneath, maybe. I couldn't be bothered. Just take the 0 to get rid of a lot of verticals, because you've got a lot of verticals to get rid of, so the 0 does a good job of that. You can think about taking the 8, but that gets rid of the horizontal, and you actually don't have that many horizontals to get rid of. So the 0 seems like a sensible one to take straight away. Then you can take the 8 maybe to get rid of a lot more horizontals, a lot more verticals, and just see whether it works. You've now got 2 verticals and no horizontals left to take. And look, when you look at that, the 1 does a good job to do that. So they add up to 9. Yeah, I just tried a bunch of stuff until I found the one that worked. Question 17 is the first one of the questions where we're just going to make something up. So I'm going to say that a fresh mushroom weighs 100 grams. So therefore 80 grams is water and 20 grams is like actual mushroom. When the thing dries out, that 20 grams of actual mushroom doesn't change, right? So when dried, it still has at least 20 grams in it. If 20% of it is water, that means that 5 grams is now water. The dried must be 25 grams because you still have 20 of mushroom, and then 5 of water would be 5 over 20 is, I think, hopefully 25%. Sorry, 5 over 25 is 20%, right? 5 over the total. So we can just sort of work our way backwards to work out what the amount of water must be in there. So the percentage that it's decreased is where it's gone from 100 to 25, right? So it's decreased by 75%. Good. Question 18. How many 8-digit numbers can be written like this? Well, if you start with a 1, I decided firstly to just get an idea for how this works by using 3 digits, and then realized that probably wasn't an amazing idea. But it did tell me, really, that if you start with a 1, you must have a 2. And if you start with a 3, you must have a 2 in the second slot. And then you get these choices afterwards. Now, the 2s seem to be a bit different, right? If you start with a 2, because then you can have a 1 here, or you can also have a 3 here. I think I didn't even bother listing out. I just noticed that 2 did something different to the others. So what I decided to do was just start with a 1, and then you must have a 2 afterwards. And it doesn't matter how long you're going to do this for, but you must have a 2 afterwards. And then you can have either a 1 or a 3. You've got a choice, either 1 or 3. But after you put a 1 or 3 here, you must have a 2 afterwards again. And then you can put a 1 or 3. Then you must have a 2, then 1 or 3, then must have a 2. And that's 1, 2, 3, 4, 5, 6, 7, 8 digits. And there are only really 3 choices here, each with 2 options. So that's 8 numbers you can make in total. But also that's exactly the same as if you start with a 3, where you then have a 2, then a 1 or a 3, then have a 2. So there are another 8 ways to do it if you start with a 3. Now, if you start with a 2, this whole thing kind of works the same, except the repeat comes one earlier. So you start with a 2, then you can choose a 1 or a 3, then a 2, then a 1 or 3, then a 2, then a 1 or 3, then a 2, then a 1 or 3. And you have 4 choices of the 1 or 3. So that's 16 ways to do it if you start with a 2. So just listing out these very basic ones gave me a sense that the 2s were different, and then I just decided to do it separately like this. 8 plus 8 plus 16 gives me 32 ways in total. 50 girls sit in a circle. So let's call this person Frida number 1. She's going to pass it to the person 6 places along from her. So that would be number 7. And then 6 places along, you can just do the 6 times table adding 1. And you get to the 49th person. Now, when that person passed 6 along, the person next to them is 50, which is 0, we could call it. Then it goes to Frida, who's next to that, which is 1. And instead of this being the number 55, it's essentially just the number 5. 6 above 49 is 55, but again, there's 50 people in the circle, so that's just person number 5, if you're starting at person number 1, I guess. And then we just add 6s a bunch of times, and then we have the same idea here, and then we add 6s a bunch of times, and then from 45, 5 people to the left is 50, and then the 6th person is Frida herself at number 1 again. And you've just got back to Frida, and you've only covered, notice, the odd numbers. You've covered all of them. If you count them up carefully, you can see you've covered all of them, but that means all 25 numbers that are even are left out, which is kind of obvious, because if you're always 1 above the 6 times table, the 6 times table only has even numbers in it, so this can only ever have odd numbers in it. So therefore, that's also a way of thinking about it. Obvious thing to do here on question 20 is to reduce 720 to prime factors, which is this. And now what you've got to notice is it's kind of easy to think, well, you can just split these primes however you want along the bottom row. They're going to multiply eventually to make this anyway. But they're not. Because if you split it like this, where you put 2 here, an 8 here, a 2 cubed, and this here, this 2 and this 2 cubed multiply to make 2, 4. And then this multiplies to make another 2, 3 times some stuff here. And then you make 2 to the 7 when you put it up. The fact that this number here kind of divides itself whilst maintaining all of its existence, that was a very grandiose way of saying that, as it goes to this box and this box, means that you can't just put the right number of times on the bottom, because this box is being duplicated. as it heads there and it heads there. So what we need to do instead is, for example, if we just put a 3 in this box, it will multiply by this here. It doesn't matter what these two numbers are really, to put a 3 here, but it will also multiply by this to put a 3 here. And then you have two 3's multiplying, which give you the right number of 3's for this number here. So this would be an acceptable way of doing it. And likewise, putting two 2's here, because then you'd get two 2's there and two 2's there to make 4 2's in total, which will work perfectly well as well. Or you could, of course, put nothing there. And when I say nothing, of course, I mean in prime factors, I mean 1, because 1 will duplicate it to still make some 1's. And this is all fine. Again, it absolutely doesn't matter what goes on either side as long as it all has the primes that are from here. And we're all good to go. However, there's a couple of sneakier cases in here as well, which is we can put we can combine this 2 squared and 3 idea. Because, again, when this duplicates, we will make in the middle here, because when this duplicates, you get a 2 to the 4 over here and a 2 to the 4. Does this work? Over there? Oh, sorry, but with a 1 over there, yeah, sorry, you'll end up with a 2 to the 2 over there and a 2 to the 2 over there, and then a 3 over there and a 3 over there, and that'll make 2 to the 4 and 3 squared, and that will work as well. Or you could do the same thing, but with only a singular 2, because then you can just use another couple of 2's over here, duplicate that 2 to make 2 to the 2, 2 to the 2, as the extra 2's coming from the sides that don't get duplicated, and that makes 2 to the 4, and then finally just a singular 2 without the 3, and that makes 6 in total. Quite difficult that, and I thought it took quite a lot of really careful thought to make sure you weren't missing a case. So yeah, not an easy question. Fee notices here that when she sells a bunch of mixed eggs, she has twice the number of ducks to chicken. But of course, that means if you just label the number of duck eggs A, that means here she has 2A chicken eggs, and add those together, and she has 3A eggs in total, which means she has a multiple of 3 eggs left. So when we add all these numbers together and then remove one of them, we need to get to a multiple of 3. You can do this. You can do some modular arithmetic if you want to, and just think about what these things are, remainder 3. Or you can just test them all and notice when you take away 29, you get a multiple of 3. And so therefore, that's it. This question took me, I'm going to say, somewhere between 1.3 and 1.4 seconds to do, because all you have to notice is that this half of B slots perfectly in there, because it's sort of making an angle of 1 across 3 up. So it slots perfectly in there, sort of if you put it backwards. Or you can put this side of it straight in there, I guess. And then this angle here you can put straight in there. And then you have 2 full angles that are both 45 degrees, and so they both add up, of course, to 90. Question 23. Now, the key line here is that the other 3 lied in all of their answers. So let's just say that Tom is telling the truth, and that so therefore these 3 numbers need to add up to make 30, which means this one needs to be a 10. Now, the thing is, that means there are 10 gold, there are 9 silver, and there are 11 bronze. And the other 3 lied in all of their answers, except Pitt said that there were 10 gold, which isn't a lie. So therefore, Tom can't be telling the truth, because then Pitt wouldn't have lied on his singular answer here. Al, if he was telling the truth, there would be 11 left here. I hope I haven't done the maths wrong. No, that's fine. And that's not inconsistent with anything else. No one else has said the same number as him on anything. So maybe Al is telling the truth. Pitt would need a 10 here, which would imply Jim was telling the truth about the number of silver, which can't happen. And Jim would require an 11 here, which means Tom would have been telling the truth about bronze. That can't happen. And Al is the only one that has any feasible chance of working. 24. Alex tries from point P to point Q. This is the second question of the challenge where we're just going to make something up. We're just going to say that Alex's speed is the incredible unit 3 meters per minute, only because he's asking in minutes. And therefore, Bob's speed is 1 meter per minute. So after 15 minutes, Alex has gone 45 meters this way, and Bob has gone 15 meters this way. Perfect. How long after the start will they meet each other for a second time? So let's just draw the situation again, and let's just guess 20 minutes later. Now, be careful here, because there's a trick in this question. How long after the start? Not how long after this situation here. How long after the start? So if I'm saying 20 minutes later, I'm actually saying 35 minutes after the start. So I'm actually testing this answer here by using this case. So, okay. 20 minutes later, Alex has gone 60 meters, of course, based on my ideas here. Bob has gone 20. So if Bob's gone 20, he's now 25 meters from this end. And if Alex has gone 60, he's done 15 plus 15 is 30. And now he's gone another 30 this way, which puts him 15 away from this end, which means he's actually already passed Bob. So it must happen slightly less than 20 minutes after this, so slightly less than 35 in total. So obvious thing to try next would be the 30. So 15 minutes after this situation here, Alex has gone 45, Bob's gone 15. So therefore, Bob is now 30 minutes from the start. Sorry, 30 meters from the start. Alex has gone 15, 15. He's got 15 more to go, which puts him, guess what, 30 from the start as well. And so therefore, it is 30 minutes after the initial, after the very initial time. And question 25, finally, I decided to split the shape into two and just ignore this part of it and say, well, this thing here is now 6.5, and this thing here is 10. The gray one was 10. At this point, I cut all of these shapes up based on these lines here. So like put a line there and put a line there. Now, where did these two numbers come from? Well, the whole thing was 10, if we go back for a second. So it seems a reasonable guess that if you cut it in half, it's 5.5 and 4.5. But why couldn't it be 5.6 and 4.4? Well, the reason is because of this 6.5 here. If you imagine this little triangle here and this little triangle here, those triangles are all the same because they've got the same width and they've got the same gradient going up. So therefore, all of these little triangles on the top are equal. So when we think about this shape that's size 10 in total here, and we think about maybe taking one of these triangles and hinging it at this point here and putting it down, you're going to make a full rectangle. So therefore, this shape here, if we remove some number and put it here, increases this to be the same as where this decreased to. So that's where the kind of idea of getting to 10 involves. But why can't it be 5.6 to 4.4 and this little triangle here is 0.6 moving from one side to the other? Well, because of this 6.5 here, right? Because the same triangle is doing that same hinge here. If this was 5.6, then therefore the distance between these two would be different, which is not, because it's the same triangle making that hinge each time. Therefore, it's got to be 6.5, 5.5, 4.5. Continue the trend down here will be this one being 3.5, this one being 2.5. Add all those up together, and then, of course, double it, because we are looking at two positions there, and you'll end up with 45. That's the whole paper, and thank you for watching.